All right, so we're on to division of a polynomial by a quadratic. So we have this quartic and we're dividing it by a quadratic. Now when you're confronted with something like this as well, you can just think, my answer, when I divide this quartic by this quadratic, my answer has to be a quadratic. Why is that? Because x squared times x squared would give you x to the 4. All right. Similarly, if you're dividing a quartic by a linear, okay, if you're dividing x to the 4 by only one lot of x, your answer, your quotient, has to be x to the power of 3. So you can already anticipate what your answer is going to be. We just ask ourselves the same question. What do I multiply by x squared to get x to the power of 4? The answer, x squared. And that's going to go above our x squared term. Okay? And then we perform it. We go x squared times x squared, that gives us x to the 4. X squared times minus 2x, minus 2x to the 3. And x squared times positive 3, positive 3x squared. Okay, so then we'll subtract it away. X to the 4 take x to the 4, we'll cancel. 0 take minus 2 is positive 2. 3 take 3 is 0. And we'll bring these terms down. Alright, and then like we were doing before, we've got 2x to the 3 here, and we go, what do I multiply x squared by? That's my leading power over here, my leading degree, to get 2x to the power of 3 plus 2x. And then we perform it right. 2x times x squared, 2x to the 3, 2x times minus 2, minus 4x, 2x times 3, plus, excuse me, 2x times minus 2 minus 4x squared, 2x times 3 plus 6x. Subtract that away. 0 take minus 4, that's a positive 4. 2 take positive 6, minus 4, and then plus 1. And then the last one, what do we multiply x squared by to get 4x squared? Plus 4. 4 times x squared. 4 times minus 2. And 4 times 3. 4 take 4 cancels, minus 4 plus 8, and 1 take 12. Ooh, one too many ones. Very good. Okay, so this time, notice how we have a linear factor left over. Alright, so when we're dividing by when we divide it by a linear, we have a constant left over. When we're dividing by a quadratic, we have a linear left over. If we were to continue divide by a cubic, we can anticipate a quadratic being the remainder. Okay, so let's state it how it's asked us to state it. So remember, the polynomial is equal to the quotient, what we have at the top, quotient. Okay, I'll write q of x above it, multiplied by the divisor. That's what we divided it by. And then plus the remainder. Okay. So I'll leave example B for you guys to have a crack at if you would like to. But let's talk specifically about question 2. Maybe with example B, I'll just make sure when you set it up. All right, we got x to the 3 plus 2x squared take 5x plus 1. And we're dividing it by x squared take 3. We need our 0x here. Okay, so make sure you have that term there as well. All right, so that's example B. Let's talk about 2. Now, just talk quickly about language. We have p of x is q of x times d of x plus r. And another way we can express this, if I divide both sides by d of x, I would have P of x on top of D of x here. Alright, I've got this written down in the notes, I'll point out where in a moment. And if I divide, I'm dividing both sides by D of x, we're going to have here Q of x plus the remainder. So this is an alternative way that we can dictate a relationship between polynomial, divisor, quotient and remainder. Okay? So all I've done is I've taken our fundamental expression, divided both sides by D of x, and this is another way to dictate the relationship.
Would the remainder not also get affected by dx?
Thank you, sorry. Yeah. Good. So when we divide it there, it cancels, and then plus the remainder of dx. So I'll just point out where it says that for you. It's in the next exercise. So we'll leave it for now. So question 2 then says, suppose we have x plus 3 multiplied by x squared, take 2x, plus 7, take away 5. Okay? This is our polynomial. This is what P of x is equal to. Alright, P of x equals this. Now, find the quotient and remainder when this polynomial is divided by x plus 3. So we're performing the polynomial divided by x plus 3. We're dividing this whole thing by x plus 3. Alright, so if we do that, let's split the denominator first. So let's think about x squared take 2x plus 7, all on top of x plus 3, and this one minus 5 on top of x plus 3. Now over here, x plus 3 will cancel, won't it? And so we're just left with the quadratic term. Take away 2x plus 7. And over here, we're just left with the remainder. So based off of this logic here, right, we saw if we have a polynomial, we can write it like that. We divide both sides by d of x. Okay, over here we divided both sides by x plus 3. This is our quotient. This is our remainder. This is the divisor. Okay, so the quotient is the x squared take 2x take plus 7, and the remainder is minus 5. Okay. We don't write the remainder is minus 5 on top of x plus 3 because x plus 3 is what we divided it by. Minus 5 is what's left over, what won't divide further than what we've got written. Alright, really good. So that's 2D.2. Let's have a go at some of those ones together. I reckon I'll get you guys